Hello guys. And welcome to this class. In the last classes we talked about work, energy and power, and we said that work is done whenever a force moves the body along a distance, so that W is equal to F times S. And we said that the unit of work is in joules, right? And we said if this work is inclined, then it becomes F times X cos theta. And we said that energy is the capability to do work, and we this type of energy, and that is what we are going to be doing today. We are going to be breaking into brief detail this type of energy. And after that, we said that power is the time rate of doing work, and power is equal to P. That implies that P is equal to work over time, right? We also said that P is equal to force times velocity. We showed the derivation for everything here. And we said that the unit of power is in what? It's in watts, right? Okay, so the class that we are going to be doing today is going to be talking more of power, of work. Sorry, we're going to be talking more of energy, and we are going to be explaining those energy in detail. So the first type of energy I'm going to explain mechanical energy last, because there are some mathematical derivations that I will do there. So we are explaining that last. And the first type of energy we're going to here is called electrical energy. And what is electrical energy? Electrical energy is gotten from electrical power. So it's called electrical energy, right? So I know that electrical energy is gotten from electrical power, and this kind of energy can be used as heating, can be used for refrigeration, it can be used for many purposes. We'll be going in detail into this type of energy when we are under current electricity. But for simplicity, let us just drop some formula. You can write them down. But electrical energy, I will derive them when we get to current electricity. It's not much important. The first one is I is equal to I. Are we there? IVT is equal to E is equal to IVT. And another one is another formula for electrical energy. It's E is equal to V square times R. Are we there? Times T. And the last one is E is equal to I square R times T. So those are the three formulas we know. And I is for current, V is for the voltage, and R is for the resistance. You can write them down. We are not going to be using. We can be using those formulas, but not that much until we get to current electricity, or when we solve a past question that implies using those formulas, then we go. And the next one we are going to be talking about is called, the next one here is called solar energy. Solar energy is an energy gotten from the sun. Solar energy is an energy gotten from the sun. So solar energy can be used as heat, can be used because from sun we get heat. Solar energy can be used as electrical energy, can be converted from solar energy to electrical energy. Solar energy can be used for many things. In fact, from the sun we get light, right? So solar energy is another type of energy. Alright, so the next type of energy we talk about is elastic energy. So elastic energy is the energy stored in an elastic material, like in a spring. We know that some elastic material like catapults can be able to do some kind of work. For example, for me to be able to throw a stone along a far distance, I might put it inside the catapult, and when I stretches the elastic cord, and I discover that the stone moves. Now, for that stone to move along a distance, that means work has been done. And for work to be done, there is energy involved. That means that the catapult has energy, and this energy comes from the energy of the elastic material. So there is an energy stored in the elastic material, and the formula for this, I'm not going to derive it until we get to elasticity. I will derive it in detail. The formula for this energy for elastic material, or the energy stored in the spring, E, are we there? Is equal to K E square. E is equal to K E square over 2, or 1 all over 2 F E. The K here stands for the spring constant. The spring constant. And the value for the spring constant is Newton per meter. E here stands for the extension. E stands for the extension, and F here is the force, right? I know that the unit for force is in Newton, and unit for extension is in meters, right? Alright, so write this down. The next one we go to here. Alright, so like what said, there are many types of energy. Because of time, let us just go straight to let us go straight to mechanical energy. Alright, now in mechanical energy, it's in two types. Mechanical energy is in two types. Number one, we have the kinetic energy. Number two, we have the potential energy. So we have kinetic energy and the potential energy. Now, what is the kinetic energy? The kinetic energy here. The kinetic energy is the energy that a body possesses due to virtue of motion. When a body is in motion, the energy it possesses is called kinetic energy. And the formula for kinetic energy is given by E is equal to 1 over 2 mv squared. That is 1 over 2 times mv squared, right? This is the formula for kinetic energy. And to derive this is very easy. Let me derive this equation so that we know how it comes from. We know that energy is equal to work, right? Because energy is the amount of work you've done. So we know that energy is equal to work. That means E is equal to W, and work is equal to force times distance, right? Now the force involved here now is force due to motion, and force due to motion is equal to mass of the body times the acceleration of the motion, right? Acceleration. So everything here is now ma. Then we bring our s here, right? Now we know that ma here s. We know that from the equation of motion, from the third equation, I know that v square is equal to u square plus 2as, right? Now if we make as subject to formula, as will be equal to v square minus u square all over 2. So if we substitute v square minus 2 square minus u square over 2 into this place. It becomes ma multiplied by v square minus u square all over 2, and this implies, if we continue from the other side, ma is equal to v square u square over 2. I'll write it like ma is equal, sorry, that's m v square minus u square over 2. Now, when we imagine that the body is starting from rest, that means that u is equal to 0, right? Although this is the formula, but when we don't have an initial velocity, we just talk about the instantaneous velocity of the body, the velocity which the body is moving at that time. So we can say u is equal to 0, and we have only mv square over 2 here. And factoring out 2, that is the same thing as 1 over 2 mv square. So this is the derivation of kinetic energy. E is equal to 1 over 2 mv square. Alright, so make sure you write that formula down. It's very important. The next type of energy we have been going to, sorry, this video is a bit long, but we need to cover things up so that we can go further. The next type of energy here is called the potential energy. Potential energy. What is potential energy? Potential energy is the energy stored as a result of the height of a body from the ground, right? We know that if a coconut falls from the roof of a house to the head of a person, and on another instance the coconut falls from a very high tree, that is from a coconut tree to the head of the person, we know that the one that falls from the roof of a house will have less effect than the one that falls from high tree. Although these coconuts that fell at both instances are of the same masses, but the distance matters a lot, and the contribution to the distance is as a result of what potential energy. So potential energy is the energy that the body possesses due to its height from the ground. You can write it down. Due to its height from the ground. It's the energy that the body possesses due to its height from the ground. So we are going to be deriving the equation of potential energy from the ground. Because of time, I won't derive this equation. I won't derive it. If you want to know about this, you can message me or you can search it online. But just know that the formula for potential energy is PE is equal to mgh, right? Where m is the mass of the body, g is the gravitational acceleration, and h is the height of the ground, the height from the ground, right? So which means that if we have higher value of h, then the potential energy will increase, right? So if the value of h is less, the potential energy will be less. So which means that the potential energy is directly proportional to the height of the body from the ground. So what we can summarize here is that we have kinetic energy. Kinetic energy is the energy a body develops as a result of motion and is given by Ke is equal to 1 over 2 mv square. Ke is an acronym from kinetic energy, and Pe is an acronym or is the short form for potential energy. Alright.